If you're asked to come up with a data table for a function, that means they're looking for something like this. Something where you have x and y values that represent coordinates for the data table. And you can start off by plugging in 0 in for x, which means you go over here and everywhere where you see an x in your function, you plug in 0. That's going to leave me with 5 when we're all said and done. There's one piece of the data table. And we want to do it again. Maybe you want to plug in 1 for x and see what you get. So I plugged in 1 in for x, and sometimes students want to get tempted and square the -3. That squared only applies to the x variable. So the 1 squared is going to be 1. -3 times 1 is -3. So we got 2 for x equaling 1. And we want to try some negative numbers too. Try x equals -1. Plug -1 into your function. And now -1 times itself is +1. So we're going to get out a 2 as well here. You want to keep going through in the same fashion. Plug in 2. And if you plug in 2, that's 4, 12. So you should get -7 if you do the same steps. Plug in 2 and solve. Do the same thing with -2. You get -7. That's the data table they're looking for. And we like data tables like this because it gives us a rough sketch of what the graph should look like without a graphing calculator. At 0, 5, I'm going to put a dot. Oops. That's not really on the line. There we go. At 1, 2, I'm going to put a dot. At -1, 2, I'm going to put a dot. At 2, -7, I'm going to put a dot. And at -2, 7, I'm going to put a dot as well. And those dots start to form that parabolic shape that we're used to seeing with a quadratic. So without a graphing calculator, oh, that dot's off actually, it should be down here. Without a graphing calculator, I got a sketch of what the graph should look like.